In this video, we will be solving this question which says Burt's utility function is u of x1 comma x2 is equal to x1 plus 2 multiplied by x2 plus 6, where x1 is the number of cookies and x2 is the number of glass of milk that he consumes. So based on this information, we are asked what is the slope of Burt's indifference curve at a point where he is consuming the bundle 4, 6. Use pencil or black ink to draw a line with the slope through a point 4, 6. Try to make this graph neat and precise since details will matter. The line you just drew is a tangent line to the consumer's indifference curve at the point 4, 6. Here we are asked to find the slope of Burt's indifference curve. Now what do you mean by slope of Burt's indifference curve? In economic terms, MRS or your marginal rate of substitution measures the slope of indifference curve at a given bundle of goods. It can be interpreted as the rate at which consumer is just willing to substitute a small amount of good 2 for good 1. Mathematically, your MRS is equal to the derivative of x2 with respect to x1, or it can be written as minus of mu1 divided by mu2. Now what do you mean by mu1 and mu2? Your mu1 is nothing but the marginal utility of good 1 and mu2 is your marginal utility of good 2. So let's quickly revise the definition of these marginal utilities. Your marginal utility of good 1 measures the rate of change in utility, which is represented by del u, associated with a small amount of change in good 1, which is represented by del x1. Thus, your mu1 is the partial derivative of the utility function with respect to x1. Similarly, your marginal utility of good 2 measures the rate of change in utility associated with a small change in the amount of good 2. Thus, your mu2 is equal to the partial derivative of utility function with respect to x2. Now keep one thing in mind: when we are partially differentiating any function, then we have to keep the other variables constant. Now what do I mean by that? Now here, since utility is a function of two variables x1 and x2, and when we are partially differentiating the utility function with respect to x1, then we keep x2 to be constant for the calculation purposes. Similarly, when we are partially differentiating the utility function with respect to x2, we will keep the other variable, which in this case is x1, to be constant. So here your x1 will be constant. Now after revising the definitions of marginal rate of substitution and marginal utilities, let's calculate the MRS at bundle 4, 6. From here you can see that for MRS we need to first calculate the marginal utilities. So your marginal utility of good 1, which is your mu1, is equal to the partial derivative of utility function with respect to x1, which is your del u divided by del x1. And now in this particular question, the utility function is taking this form where u of x1 comma x2 is equal to x1 plus 2 multiplied by x2 plus 6. Thus we have to partially differentiate this expression with respect to x1, and since it's a product and we are partially differentiating, thus your x2 becomes a constant and hence it will remain as it is since it's in multiplication. So that would be x2 plus 6. And now we have to differentiate x1 with respect to x1, which is 1, plus the derivative of 2, which is a constant, and the derivative of constant is 0. So this is 0. Thus your mu1 is nothing but x2 plus 6. Now let's calculate your marginal utility of good 2, which would be the partial derivative of utility function with respect to x2. Again, we will be treating x1 to be constant here, and since x1 is constant, it will remain as it is since it is in multiplication. So that becomes x1 plus 2 multiplied by the partial derivative of this, which is x2 plus 6. So that would be the derivative of x2 with respect to x2 is 1 plus the derivative of 6, which is a constant. So that would be 0. Thus your mu2 is x1 plus 2. Now substituting the values of mu1 and mu2 into this expression, we will be able to get your MRS. Hence your MRS is equal to minus of mu1 divided by mu2. Your mu1 is x2 plus 6. So that would be x2 plus 6 divided by mu2, which is x1 plus 2. Thus your general expression for your MRS is minus of x2 plus 6 divided by x1 plus 2. But the question asks us to calculate the MRS or the slope of Burt's indifference curve at the point where he is consuming the consumption bundle 4, 6. That means we have to evaluate the MRS at 4,6. And for that, all we have to do is substitute the value of x1 with 4 and x2 with 6 into this expression, since this is your expression for your MRS. So that would be minus of x2 plus 6. At this point, your x2 is 6. So that would be 6 plus 6 divided by x1 plus 2. And your x1 is 4. So that would be 4 plus 2. Solving this, you get minus of 12 divided by 6, which is equal to minus 2. Thus, your slope or MRS of Burt's indifference curve at the point where he is consuming the consumption bundle 4,6 is minus 2. The question further asks us to use pencil or black ink to draw a line with the slope through the point 4,6. Now, in order to draw a line having the slope of minus 2 and passing through the point 4,6, we need to first find the equation of the line, which is the equation of a line passing through one particular point and having a given slope is this, which is y minus y1 is equal to mx minus x1, where y is your y coordinate of second point, y1 is a coordinate of point 1, m is your slope, x is a coordinate of second point, and x1 is a coordinate of point 1. Here, in our case, your slope or m is equal to minus 2. We have the line passing through the point 4,6, which gives us the point as x1, y1, which is equal to 4,6. Thus, your x1 is 4 and y1 is 6. Now, all you have to do is just substitute these values into this equation and you would be able to get your equation of a line passing through one point and having a given slope. So, that would be y minus y1, which is 6, is equal to m, which is minus 2, multiplied by x minus x1, and x1 is 4. Now solving this, you would get that y minus 6 is equal to minus 2x plus 8. Or rearranging this, your equation of the line becomes y plus 2x is equal to 14. Now we have to draw this line on the given graph. We are given this graph where on the x-axis you have cookies, that is the number or x1, as x1 is the number of cookies, and on the y-axis you have glasses of milk, or x2 as given in the question, that is x2 is the number of glasses of milk that Burt consumed. So on the x-axis you have cookies and on the y-axis you have glasses of milk. And your point 4,6 lies here. Now you have to draw a line passing through the point 4,6, which represents the same slope as the slope of indifference curve for Burt. And as we calculated here, that the slope is your minus 2. And the equation of the corresponding line would be y plus 2x is equal to 14. Thus, this line will look like this. Hence, your black line is a line with the slope of minus 2 through the point 4,6. And note that this line we just drew is a tangent to the consumer's indifference curve at the point 4,6. We will do the remaining parts in the next video.